Okay, so I taught you about classes, I taught you the Python fundamentals, things like printing to the screen, things like what variables are, functions are, types of data types, etc. And also for anyone who's already experienced for Python, you're probably here because you skipped the other videos because now you want to actually apply Python to Vex robots. Now, before I actually get to doing it specifically for Vex robots, first I just want to explain how to instantiate or how to make instances of the classes real quick for the people who are beginners. So if you're experienced, just look for the part in the video where I delete this, or where I delete like a chunk of this. Okay, just skip to that part. Anyway, so now for people who are still learning, when I'm calling my library, right? Or when I'm getting my library, right? Usually it's just import Vex. Usually this is all I have to write. But because Vex is a very big library and it has a lot of actually sub-libraries, interestingly, and yeah, it's just a big library. So instead of just doing import Vex, you have to do from Vex import all. So this asterisk means all. So we import the Vex library, correct? Now I'll just give you a brief idea of what is going on here, just like a small idea. So motor is the class. Motor is a class, right? As I mentioned. And brain.port2, right? That's an attribute. I'm telling it that the motor is on port 2 of the brain. That's an attribute of the motor. So again, in the instructions that it gives to the motor, it'll say route it through this port on the brain. It's just the way the method executes will be slightly different. Ultimately, the code's the same, but it's just the execution will be a little bit different. So right, I have this motor class with this attribute, and I make an instance of the motor and call it left lift motor. I do the same thing for the right lift motor. And again, I create the class motor with the attribute and this instance name. Similarly, I call a method from the class motor. I'll give it a parameter. So kind of like in a function where you have to give it arguments, right? You have to give arguments sometimes to methods as well. So you'll see that. And then again, I do the same thing from this other class and this other class. Okay. Now I'll get rid of this. People can come. Okay. So now we're going to talk more specifically about what's going on. First of all, when you have your Vex robot, you have to make sure you make an instance of brain because brain is kind of the most important part of your robot, right? So we get the ports, right, from having brain over here. Actually, if you look in here, we already defined brain, but that's okay. Just for your understanding, I'll define it here instead. So we have this brain, right? And we make the instance of a motor. We call it the left motor. And inside motor, we give the specific port that it's located on. Because in order to do stuff to the motor, it's going to need the location. It'll do the same thing for any type of motor. And then it calls the method spin to actually do the action to the motor. So if you want the motor alone, just a motor individually to spin, right? All you do is on the instance of the motor, you use the method spin and you put in the argument forward, or you can put in reverse if you want to spin in reverse. There's also other methods you can use, such as spin for. Hang on, let me just. So here are the many other methods you can use. You can use motor.stop, motor.underscore spin for, spin to position, spin alone, set position, is done, question mark essentially, get the torque that it has, or the direction it's spinning in, or whatnot. So there's all these options, okay? If you want, you can look into what each method does by going to the um, documentation, which I'll link later on at the end for the resources stuff. And you can look more into this. You can look at the other ones. And as you see, it has the different parameters you can put in and whether they're required or not and whatnot. So yeah. there's this documentation. So we have spin, right? Just for basic spinning. Now keep in mind when I do spin, it will infinitely spin forward. It won't stop just because I want it to stop. I actually have to specifically say right motor dot stop. I have to actually tell it to stop. Otherwise, it'll just keep spinning. And that's particularly important to remember when you're making your auton code. It won't just stop unless you use spin for, of course. Now, there's that, right? The stop method and the spin method. Then there's also motor groups. So motor groups is another way of putting motors. It's essentially, as it sounds, grouping multiple motors together. So I have the left motor and the right motor of some subassembly called lift. And I grouped them by using the motor group class and putting it under the instance name lift motors. And now I call the method spin onto the lift motors and it spins in the direction forward that I specified. Again, there's differences between the methods. There's a lot more commonalities between motor and motor group, but there's a few different things, I believe. I'm not sure. Might be the same actually. But anyway, so again, you can find the documentation, other methods that you can use on here. And similar to how the motor alone works, where you have to use stop, you still have to use stop here. Anytime you use the spin method, you have to use stop. Otherwise, it'll infinitely spin. Finally, I have another type of class called drivetrain. And drivetrain essentially is exactly how it sounds. It's where the computer understands or the code understands how your motors are. Like there's a left side and there's a right side. And it knows that in order to turn, you're going to only spin one, or you're going to spin one side in the opposite way and one side in the forward way, right? So drivetrain actually understands that. To make it, ideally you would put your motors into a motor group and then the motor group in the drivetrain, or you could just put the motors individually into the drivetrain. It will still work. And you can give it this extra parameter, extra attribute. So the attribute units can equal millimeters. So I specify the units I want to be. And there's more things you can specify like that. So if I go to, where's drivetrain? Am I like blind? Oh, there we go. No, so drivetrain has, these are much different compared to the motor ones. So it has drive. Drive means just drive, like straight, yeah, straight forward or straight backward. It's going to be either forward or backward, or forward or reverse, sorry. Then there's also drive for, so you give it a certain distance, or you give it, yeah, you give it certain distance, and you might give different um, units and whatnot. And there's even more um, parameters and arguments you can specify. And of course, there's these other methods, including stop. You need to use stop as well for drive. So I didn't use it because I made a mistake, but you should use it. Now, here's the problem with drive and turn, right? When you drive, when you're driving your chassis, you can only drive, stop, and then turn. It's not going to be while you're going forward, you'll start turning. It's going to be essentially stopping your chassis, then turning, then going forward again. So you can't really make a curve, but rather you have to make complete 90-degree turn every time. And I made this photo so you have a little bit better understanding of what the computer's interpreting the motors to be like. But when you use drivetrain, either it has like a left side and a right side, or it understands it as this is my left side connected to this is my right side. So it can only ever move forward, backward, turn these two in one way and then these two in another way at the same time. It can't have them like these spinning forward and these spinning forward, but at different velocities, which would be to turn while moving forward. That's the downside of using drivetrain. I personally don't recommend using drivetrain because once you code it and you find out that problem about the turning situation, I don't think you'll like it, nor will your driver. But you can try, I guess, if you want. Then there's motor group, right? Motor group is, it understands the motors to be part of this group. And then you can group another side, like the left side, to be another group. You could just say right side dot spin forward, left side dot spin forward, and then the whole thing will move forward. Or you could do left side reverse, and then it'll start turning. then you can also just use motors individually, and so it understands each motor individually. The problem with individual motors is that you have to say spin for every single motor individually, which is fine for subassemblies because you probably only have one or two motors, but for a chassis where you might have like 4 or 6 motors, you probably would want to use a motor group or a drivetrain. But again, I don't suggest drivetrain for the reasons I mentioned earlier. So yeah, actually using drivetrain is probably the simplest, but because it's simple, it has fewer capabilities. You can't like give it specifications. So although you have to say left motors, if I have this motor group, although I have to do dot spin forward and I have to do dot spin forward just to get my chassis to move forward compared to this one line, you have to do 2 lines. This actually will be a lot better in the long run, in my opinion. So I suggest get used to using motor groups rather than using the drivetrain class. But yeah, so that's essentially all it is about using motors. You probably will want more specific methods to the situation you're in. So instead of just drive and stop and turn, you might want to do turn for, drive for, velocity, setting velocity and whatnot. That's where you want to look into this documentation. So I'll have these options, I'll have the different classes you can choose from motor, motor group, and whatnot. This is a very powerful resource. There's nothing wrong with not having everything memorized. You can still come back to this whenever you need. It's perfectly fine. So yeah, that was mostly all about motors.